everyone. So this would be a little bit of a final section for our simple chemical reactions. Right? I did the word equations and the difference between the physical and chemical changes. So right now we're going to part 2 of the chemical reactions. Earlier on, you would have known how to write the word equations. This time we will be basically going into further reactions. Okay, so let's start without further ado. Okay, so a couple of things. I decided to place the lesson objective today because this is important for you to know which is which, all right? You're going to identify chemical reactions caused by heat, and there are 3 different types: thermal decomposition, combination, combustion or burning, and we have mixing of acids and metals with the carbonates. So make sure that you have this with you all the time because this is really important. The fact that you have written your word equations and practiced that a little bit makes sense because we are coming into these reactions. And the last part of all is to describe and carry out tests to identify hydrogen, oxygen, and carbon dioxide gases. So we will go into this, so please pay close attention. Now, the first reaction that we're going to do here is thermal decomposition. So basically from the name itself, thermal is heat. Decomposition here means break down. It is the process of breaking down complex substances to simple ones. So basically, if you have something like a copper carbonate, now copper carbonate is only just one reactant followed by the arrow. So in this case, if we are going to write it, we can say copper carbonate breaks down into copper oxide and carbon dioxide. All right, thermal decomposition here requires heat. All right, and we don't really write the heat in the equation. We put it as a symbol, but that is not so important in this part. All right, the important thing is that you know and understand how to write a word equation. All right, so this is a thermal decomposition, and as a result, you will get carbon dioxide as a byproduct. A byproduct here refers to something else besides the product that's formed. That's why it's called byproduct. All right. Now, combination here is basically 2 or more reactants combining to form a new product. So as you can see, magnesium and oxygen with the picture at the back here tells you that it has reacted with oxygen to produce a white powder called magnesium oxide. And we shall see that when we do our experiment, yeah? The third one is called combustion. It is when you burn a substance in oxygen gas, and one of the most popular substances is petrol. Okay, so basically for this we would actually look into combustion when we do the energy resources topic. Okay, now there are 2 types of combustion: complete combustion and incomplete combustion. Just have a look at the 2 equations. What is the difference? If you can spot the difference, you can see that soot is produced when a combustion here is incomplete. All right, so I think this will be a little bit confusing for you. So the top part here is the complete combustion. The bottom part here is the incomplete combustion for you. Okay, so for an incomplete combustion, it basically has limited oxygen. So as a result, your products produced are different. Carbon monoxide, water, and soot. Soot is actually the black carbon powder that you see that's been formed. All right, and it will release less heat and light than complete combustion. All right, if you look at the 2 Bunsen burners over here, you will notice that one Bunsen burner has the non-luminous light and the other has the luminous. The luminous is an incomplete combustion. The non-luminous here is a complete combustion. So when we talk about a complete combustion, it is where there's lots and lots of oxygen, all right, lots and lots of oxygen, and produces carbon dioxide and water as the byproduct. Water is the byproduct basically, yeah? All right, so when you look at these 2 equations carefully, you will note the difference, all right? So please take note of what you're reading here. The next one here would be on acid reactions, okay? Acid reactions, as I have mentioned before, there are 3 different types of reactions that you will go with. One with metals, the other is with bases, and one is with carbonates, okay? So let's go for acids and metals. Okay. Now, we will not be doing the acid and bases, but we will do the acid, metals, and carbonates to concentrate on, yeah? Okay, so an acid reacts with a metal to form a salt and hydrogen gas. So if you can see over here, your acid and your metal are both reactants. The salt and hydrogen gas are your products. Now, I want you to focus more on the word equation, but if you look at this balance equation here, the balance equation is where you learn in grade 9 on how to balance it. But basically, it is trying to tell you there is a conservation of the mass. So whatever you have from the left-hand side will be equivalent to the right-hand side. Okay, so I wouldn't worry too much, but if you look at this and some of you are quite sharp, you'll be able to see that both sides are balanced. Two hydrogens, one magnesium, and two chlorine and two chlorine. Okay, so hydrogen gas here is produced as a byproduct to denote that the chemical reaction has occurred. Remember the chemical changes, the evidence that you're supposed to collect to identify a chemical change? Well, hydrogen gas is basically one of the, not symbols, I wanted to say symbols, one of the evidences, yeah? And we normally don't call it as gases, we call it as effervescence, okay? The next is the acids reacting with carbonates, right? Carbonates is basically compounds that releases carbon dioxide. Hence, if you were to think of drinking Coke, for example, Coke does contain carbon dioxide. And we do know that all carbonated drinks, all fizzy drinks will have carbon dioxide. And it can be observed as bubbles of gases. Okay? So you basically have this here that you will need to look into. Right? When we come back, and I keep my fingers crossed that we can actually do your experiments, all right, we will be looking into the different reactions, all right, and we will do the activity straight up and you will understand why I'm talking about, okay? But as we all know, any word equation will have reactants, which is actually the substances on the left-hand side of the arrow, and products, which is on the right hand side. Okay, don't worry about the chemical equation or the actual equation, just focus on the word equation for now. Okay, there is another process that will break down, all right, break down compounds, and that would be electrolysis. Electrolysis here is a process that you break down a substance using electricity, where currents or the electricity is passed through water. So as you can see over here, for example, you will have normal water, and if you add an electrolysis in terms of the battery as the energy source, you will break water down to hydrogen gas and oxygen gas. Okay, so this is what you need to know about electrolysis. Now, having said that, because a lot of the chemical reactions will require chemical evidences, there are a couple of tests that you can use to actually determine what type of gas it is. If it's the pop test, we actually use it to determine that there is the presence of hydrogen gas. So all you need to do is to insert a lighted splint into the test tube full of the hydrogen gas, and as soon as the splint were to be extinguished, a pop sound would be heard. All right, so some of them can be loud, depends on how much you put inside. Okay. Second one here would be oxygen gas. To determine whether it's an oxygen gas, you make sure you have a glowing splint as a test. So what you need to do, light up the splint, blow out the fire, and place the glowing splint into the test tube, where the splint here will relight because of the presence of oxygen. Okay, so do go through these steps and make sure that you know what you're supposed to do. It's actually simple, but you just need to make sure that you understand what you are reading, what you are writing, and what you're deciphering. Okay? And last of all is carbon dioxide gas. We use it to actually be tested by lime water. Rather, let me rephrase this. We use lime water as a test to determine whether carbon dioxide is present. Okay? So basically, what you need to do here is the lime water is placed in a test tube, okay, and you mix it, you place it in a test tube. One of the easier ways is to actually blow out because when you blow it out, you will release carbon dioxide. Remember, as human beings, you take in oxygen and you release carbon dioxide. So when carbon dioxide is released, you will be able to channel it into the test tube with the lime water. And notice that the lime water will turn chalky because that is basically trying to indicate that carbon dioxide gas is present. There is oxidation definitely taking place in there. Okay, so this is really more or less to identify what sort of reactions that you are going to learn for this particular session. So my encouragement and what I want you all to do is do take down the notes, because I will be going through quickly in the classroom and we'll be doing more experiments rather than the theory. So the theory here would be something that you can learn online, but the practical is something which you can't really do it unless you're in the laboratory. Okay. All right. Thank you very much. I wish you good luck, and just make sure that you also finish the assignment online. All right. Thank you.